Он, кстати, на английском. Ох.
Okay, so colleagues, good evening. So today, Timofei Ryko will present a talk on how to make explanator data analysis. Awesome. Thank you very much, Timofei, that you agreed to make a talk. Please start.
Thank you. And I'm very excited to have my first talk in English. I hope it will be not so bad. And our topic is how to make your EDA awesome. And I will talk a bit about my library called EDAwesome. Just a bit about myself. I'm product owner at Hivex. We are developing I'm developing an internal startup, which is a platform for professionals in biotechnology. I think some people are interested in it, so stay tuned. We are launching like just in 2 weeks, I guess. Sometimes I'm a data analyst because in startups, you always do everything. Everyone does everything. I'm also finishing a data science program at Turing College. So generally, I have done many projects involving exploratory data analysis, and I didn't like that I need to do some, I don't know, similar things. So I decided that it would be nice to automate it somehow. That's why I've created my library I'm going to talk about. Here are just all the links to me if you want to discuss something, etc. My nickname is Timofei Ryko. At least everything. And by the way, I'm seeking for a job right now. In the presentation, there you will find links to the CVs. So what is my target audience here? Like why I'm giving this talk? If you are a newcomer in data science, programming, bioinformatics, etc., then I hope you will learn useful hacks to improve your coding skills. Actually, professionals, I also welcome professionals who don't like to code, like some data scientists more like to code, and some data scientists are more about science, about data. Like there are 2 types of people, and I will try to convince you that at least a bit clean code is easy and beneficial for you. Sorry for typo. And probably you will find my library useful because you don't like to code, and this library allows you to write less code. And professionals who like to code and can do it very well. I'm really excited to discuss coding for data analysis topic here.
Размьють тебя, Тимофей.
Yes, probably you can make me a co-organizer or something like this.
This version of Zoom, I think it's impossible.
Okay. Okay, so just unmute me. So let's start. And I wanted to start with the question, why do we use Python? It's maybe strange, but actually it makes sense, because why don't we just use Excel for data analysis? Well, Python is programming language, as we all know. Programming is about automation. And actually, I think that usually we don't use this power. Like, well, yes, we use programming language, but we don't use programming power in our notebooks. So I believe that Python is not better than Excel, because when you just write, I don't know, call pandas, and you just do some things every time, and you do it so that it's kind of the code which you cannot reuse. Like you usually just create some notebook, and your colleagues cannot even run this notebook, etc., etc. It's not actually better than Excel, and I will now explain why I think so. Since Python is not better than Excel, at the beginning, I will talk just a bit about Python itself, like in general. So unlike Excel, code is readable. Like I've tried Excel a bit, and when you really try to do something quite complex, you use these formulas, and these formulas are very complex, and nobody can actually read these formulas. That's why I think we don't have so many libraries for Excel like we have in Python, because you cannot just share it. You cannot, I don't know, contribute to some Excel project to improve it, etc., because you can't read it. So yes, we can read the code which is written by other people, but only if we write it properly. So just as a reminder, some important principles, I guess. Variable names should be not random. They should tell what is the thing. So here is just quick example. Imagine we have some data which we want to annotate. We read this data. We also create a data frame where we're going to place our annotations. And there's also other DF data frame, which is to explore the tool which we are going to use. Doesn't matter in this case, but just some tool. And well, imagine if you have created def1, def2, and someone who skipped this part, like where you define these data frames, trying to read something like when you write some data into a df1 using df, and you also, for some reason, check df2, and what's going on? It's really not clear. But if you just really, without any effort, call them counts df, which is data, annotation df, and by marked attributes df, it is very clear, and just do it. I mean, just when you create some variable, just think for a second. Also, a few words about comments in notebooks. Generally, comments should answer the question why this code is like this, and some specific things about Jupyter notebooks, which we all like, kind of default for us. I believe that it makes sense to place some domain-specific things in Markdown. Also, Markdown comments about charts make sense, especially when you're doing some, I don't know, EDA, and you have some business person. They really like to understand why do we need these charts here, what these graphs means, how can we benefit from it, etc. And I suggest placing technical comments with text, just like normal Python comments, which is not so important for some person who is trying to understand your scientific idea, or someone from business, but just useful for some other developers. Finally, it's very nice when your code is expressive and concise. I mean, when you have not so many lines of code, and you can easily read it, and it's kind of concise. And you can use Python Power to achieve it. Generally, some tools which help you to do it are comprehensions, which allows you to create lists, sets, tuples. So just use them. They are very nice. Also, Lambda functions are quite useful. And generally, I encourage you to check real Python for some, like for any topic related to Python. it's I think the best resource to learn something about new Python features, etc. It's very simple, in very simple words, but even professionals say that there are not so many mistakes in real Python tutorials. So really highly recommended. So again, why is code better than Excel? Firstly, you can reuse the code. But again, only if you write it properly. And here, I guess there are many concepts related to this topic, but I will mention just, I don't know, some basic which can be very easily implemented. It is dry, don't repeat yourself, like just see on the code you have written, and if you have a lot of similar code, you're doing something wrong. Also, divide your code into functions. Just wrap it into functions, and it's nice when it's nice because you can just import this function into your other project and reuse it. Also, it makes your code more readable because functions have names. So yes, it's also good. Ideally, when we're talking about like properly written code, you don't need to rewrite anything. So don't repeat yourself. If you have some code and you're doing something else, like adding some features, etc., you don't need to rewrite anything. And you also don't need to change already written code. So you have some function, it takes some arguments, it returns something, and to add new functionality, ideally, you just need to create new function, not modify your previous function. But it's like ideal case. Just try to imagine this in your head to understand is your code bad or not. So let's move to it was just kind of introduction about Python and general principles, but you can say that I use Jupyter and pandas, not Python. Kind of funny, but yes, it's true. And now I will try to answer the question how to use functions for export data analysis in particular. So some ideas how to use functions in EDA, like you're exploring your data, how to use functions. So I believe data loading is often similar in different projects. Like you often have some archives, some file names, which I mean some file formats which are similar.
Timofei, I'm sorry. So please share the screen again. So share and disappear.
Okay, one sec. You often have some file formats which you work with, and you can just write some good functions to work with these formats and load it into a data frame, for example. Just save these functions. I guess it's a good idea to save the visualizations you like to reuse them, because yes, with libraries like Seaborn, you can easily create simple visualization, but sometimes you want to make it, I don't know, more clear, add some annotations, etc., and it's quite a lot of code, and you need a lot of time to do it, to write this code. So don't just drop this code, but save it into function and use in the other project. Also, what is common is that pandas operations are sometimes a bit similar, and you can try to generalize some operations you do. Like an example which comes to my mind is something like replace multiple strings with a dictionary. Like you can easily replace one value with another just with pure pandas, but when you want multiple replace at a time, you can write some function and then apply to it and save this function because it's probably a common task. So here, I encourage you to just observe what you commonly do and place this code into functions. Also, you can not only save into functions some things which are often which you can use in different projects, but you can also create project level functions. Like for example, today you're exploring data and you do something, I don't know, you export something and probably in the other notebook, you're going to do some machine learning already, but you still need the same data preprocessing. Or data loading. So you can create such project level function and use it in the other notebook you have. So fortunately, pandas like functions. When you write your code as functions, you can benefit from pandas. How? So if you wrap all your code into functions, I'm not sure that it's really a good idea. But always wrap all your code into functions, but sometimes it makes sense. You can use them with apply, of course. It's the first thing which comes to mind when you are thinking about how to use functions in pandas. But actually, you can also aggregate with any function you have written, like every function which works for apply works for aggregation. Also, you can group by, like to group by condition. You can create some function to check some condition. Probably it's not specific, or probably it's like project level, but you can use it in group by. And finally, you can chain a lot of functions using pipe to be concise in functional style. So you can just create something like preprocess, load preprocess, I don't know, remove outliers, etc., and just pipe it into one beautiful pipeline. One thing which is on the next level.
Again, sharing disappeared.
Yes. One thing which is of abstraction is decorator. So let me remind what it is. It's kind of a thing which takes a function and returns a function. So it's kind of a wrapper around the function, and you can use decorators for the things you want to do on every step. So let's say that you have created some functions like preprocess the data, remove outliers, remove nonce, something else, or I don't know, impute nonce. So you do some things. And what you usually want to check after every step. Sometimes it makes sense to check how much time did this operation take, especially when you want to share this notebook with your colleagues and they reproduce it. It makes sense to check that, oh, this operation takes 2 hours. Maybe I should I don't know, go for a walk run this notebook or something like this. So it's useful information. Also, you can include something like how much memory did it use to make sure that your colleague, which have, I don't know, not so much RAM, can use it or something like this. And finally, you can check something about the data, like data frame shape. You sometimes expect it to change or not to change. You usually check it. Also, you can perform some validations on your data, like routine validations, like are there any nuns? For example, I don't know, I'm creating some ratio features and I get something like infinities because when I divide numbers, I can get this nonsense, and I don't want infinities in my data. So after every step, I check infinities or nuns or something else. You basically can perform any validation which you need, and depends on the data you have. But there is such a take that notebooks are not good for code. So just create models. So how you can name your models, something like data loading.py. As I said, there are many quite, I don't know, stupid things like connect to something, get something from there using some API, download, and I don't know, do something with some archives, etc., etc. You can just save it into a data loading model. Also, some, I don't know, common functions which you write when you use functions are pandas applyers, like something which you apply to the data frame. And for example, you create some column where you calculate something new, or you basically do many things, but you really often apply something to the data frame. So it makes sense to even divide these functions into separate model so that you can easily understand, oh, okay, these functions I can just apply to the data frames. As I said, it makes sense to save visualizations. So just create something like charts.py or something like this. Finally, something like string utils.py makes sense because like we at least always work with strings with some file names. I don't know, with some sheet, when we usually need to do something with strings. It's quite common for personally for me. So just create models, and actually Jupyter Magic can make you even more powerful when you are doing all of this. You can use timeit instead of decorators with time model. Like as I said, you can yes, thanks, and I will demonstrate in a second. You can use timeit magic. It's magic commands are kind of lines which you can write in the beginning of the cell, and they will do some magic. For example, if you write timeit in the beginning of the cell, it will print the time which is needed for the operation in this cell. It's kind of similar to decorators because you just need to write something as a wrapper and it does something with the whole cell. So you can use this timeit, but it's interesting. It's more precise than time because it repeats your operation to measure the actual time. You can set the number of iterations. but I believe it's not a good idea for very long operations, of course. So be careful here. Also, what I find useful, we mentioned that we can create functions, and to easily write it into models, you can use literally write file to save the code into your model. Something like you have function, I don't know, read SQL something, and you say write, you define this function, and you just create a cell with the definition of this function. You write file data loading.py. So it was like very quick introduction to how, in my opinion, you can you can create better notebooks. So I encourage you to, if you're a lab head or team lead, create kind of style guide and some kind of workflow for the notebooks in your team. I also believe some good structure of the notebooks makes sense when you have this markdown. It's really obvious, but it really helps. Something like markdown sections, which are called similar to load the data, get the data or something like this, clean the data, then I don't know, some feature engineering, like just sections, and as I also mentioned, some text which is domain related into in the sections. So create some style guide and just force your team members to use this style guide, and I'm quite sure that your team will communicate more effectively. Also, if you're just a scientist, what you can do, it would be nice to just attach clear notebooks to your publications. So yeah, I really like when you read some paper and for example, you want to play around with the same data. For example, I don't know, create some other visualization. You have some idea how to make it better, how to do it better, or you play with this data and do something else. And at least for every paper, you cannot just do it. You cannot just run some notebook to reproduce these results. You cannot do it. But it's really nice if reading your paper, the reader can run it on his or her server or machine and play with it. I believe that in such way we can kind of make scientific progress faster, and more people will benefit from your publications. And if you're a student, you can impress your PI with clean code because it's beautiful. Aesthetics is beautiful. So as a conclusion for the first part, which is about very briefly about good practices, I say just do it. But you may ask, what if I'm too lazy? Like, okay, nice points. You're probably right that it's good to write functions. It's good to think when you write these things. Like, for example, when you try to create proper functions, you need to think, do I need this piece of code in every project or just here? And can I really use it? How to divide this code into functions? Do I need 3 levels here or 2 levels, or what do I do? It's frustrating sometimes. So if you don't like it, don't worry. This is why I've created EDAwesome library to automate all these things. to kind of force you to create clean notebooks, because like now, if you don't like, I don't know, beautiful notebooks, you create ugly notebooks, and everybody suffers. So with this library, you can easily create such notebooks, and the world will be better. So the aim of this library is to automate all the routing, so users can focus on the data. I mean, it's sometimes not cool when you want to solve some scientific problem, you want to understand something, or you need some insight for your business, but you just cannot, waste your time on how to get some data, how to get it in right format, like especially for bioinformatics. I think it's typical when you need to convert one thing into the other thing, and this is quite stupid. Like it's not science actually, but you need to do it to do this science. Not nice. So ideally, how I see this library, what is my vision in future? At the moment, it's just very simple, kind of some starting point. But what is my vision of this library? I believe we need some clear automated EDA workflow. So if you are familiar with web development, there are some frameworks, and you, for example, you process some request. Well, okay, I don't like this analogy, but the point is that we need some workflow which is common for different researchers and different data scientists, and it is automated, something similar to AutoML, but for exporter data analysis. I will show you in the examples. Also, I believe it makes sense to create some kind of structured set of high-level tools. Like you have some workflow, some steps which you need to implement, but to implement these steps, you often need some shortcuts because you are lazy and you don't like to write code. So we need a structured set of high-level tools, which are even more high level than pandas or Seaborn. So summarizing these points, we need to introduce good practices by design of this library. So you cannot use bad practices when you use this library. And finally, we need some kind of obvious boxes to put custom components. I mentioned models, but I believe it would be nice to standardize it a bit so that if two different persons who use this library, who know this structure, can read each other's notebooks very easily. So they are already looking for some standard models, and so let's move forward. How to start with this EDAwesome? What is it? So basically, the main thing in this library is EDA object. You just create this EDA at the beginning in some
again, sharing.
Okay.
Please start sharing.
Okay. So how to start with EDAwesome? It is centered around EDA object. You just import it, doesn't matter. And you create this EDA object in the beginning, some section like import and setup. I really like this section where you define where you import all the functions or the libraries, so that when you read the notebook, you can easily understand which libraries are used, and also check the paths. Some, for example, you have some data, but you have the same data in the different place, and you can just create variable data path at the beginning and then use it. You can also create seed at the beginning and also use it so that this seed is similar everywhere, and all is good. So this first section is quite useful. So you basically just create this EDA object, and the only required parameter is data dir path. It is the date. It is basically data dir path. So full path to some directory where you want to store your data. In this case, it doesn't matter, just some library or just some directory. And you can also include some sources of the data you're going to use. In this case, I've downloaded some archive, which is zip, and I just say here are my archives. You can use not only zip but at least everything. And also, since I work with very huge data frames, I want to use PySpark, and if I don't have EDA library, I would write a lot of code to set up it, to not so much, but still set up it, start it, etc., etc. But here you just say use PySpark, and it will use PySpark for huge data frames. And you can also set limits for different ways of loading your data, like pandas memory limit means that when your data frame, when your file is more than this size, then you use PySpark. In other case, you use pandas. And here is also just a parameter for PySpark memory limit, which is 4 gigabytes in this case. So you just create this EDA object. You also can include Kaggle datasets by URL. Just copy your URL in, say, Kaggle datasets equals this URL. You can include several Kaggle datasets, and it will download it for you and unzip and all the things, and it will be in your data directory. You can read SQLite databases. It's so already implemented. And after that, you kind of do step-by-step exploratory data analysis. We introduce steps, and you can move between these steps with and in each state, but then you call load data, and it will load the data from all the sources you defined. You can also just include some data frames by hands. Let's say that you firstly created some data frame and then decided to use EDAwesome. Then so you create this EDA object, and you can just in this step you can just add data frames. After that, you move to the loaded state. data is loaded, and in this case, you already cannot add more data frames. You can only clean them, and you perform some clean operations, and then you call EDA.next, and now it's cleaned. So why we need these constraints that you cannot perform something like add data frames in clean state, because in such case you want to be sure that all of your data is processed. So you have many data frames, and you add some new data frame and it's not cleaned, and it's not nice. After that, you can categorize other columns. You just like identify what are categories, what are numerics. It is useful for one thing I'm going to show you. And on each step, you can use a set of tools which are in this EDAwesome library. So we have some functions for automated cleaning. It's very stupid for now, and we're going to improve this part. As I mentioned, we also have a lot of kind of shortcuts for data loading. So you can already just make it easier, make life easier for you with this loading. We also have a bit nice visualization, like just some nice visualizations. So let's just open some random notebook. Here is just some introduction where we understand, where we say what's going on. It actually doesn't matter. So here are imports and setup, blah blah blah, blah blah blah. Here we create our EDA object, and then we just load the data. And what it does, it loads the data, and if you don't say be silent, it's not silent, and it prints out all the data frames. So here is home credit columns description. I don't like how it's rendered on GitHub. No, not nice, but doesn't matter. Then here is a post cache balance, and here you can see some warnings from PySpark. So this post cache balance dataset is loaded with PySpark. As you can see, it's huge. It prints its shape, and here we can just call a lot of. We can just see a lot of data frames. What it also does when loading the data frames, it renames the columns in snake case. I like it because I like calling columns with a dot, like data frame dot something, because you have autocomplete in such case, and it's cool. Here, so we have a lot of data frames, okay. And we don't want to add anything else, so we say EDA.next, and it says EDA is in loaded state now. Now you can drop or impute missing values. Here are some functions. We have clean function, but it's not cool because it just drops missing values, which is not usually what we need. This is when I say that we need to like work on this thing. But there is a quite nice clean check. So when we call clean check, it checks for bad values, and it shows your nulls, it shows you some duplicates, like a lot of things. In this case, we have many columns, so it's probably not like very readable, but I believe still useful. Also, if some column has some nulls, it says sometimes when you have a lot of nulls, it suggests you to drop this column before calling clean or do something with this column. It's actually not very good suggestion. We're going to change it, but it identifies these columns. Blah, 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 blah. So you can basically, without writing at least any code, check all this information, which is usually useful. And after that, you can do something, impute something, etc., and then you call EDA.next, and now it's in clean state. And here I just call EDA categorize. It is a quite stupid function for now, which just say that all the columns which have less than n unique values are categories, but it actually generally works. Like, at least in any cases, it makes sense to agree that such columns are categorical, and some columns which have many different values and which are numbers are numerical. So we have this EDA categorize, and it says for every data set, it shows what are categories. So yes, some flags are categories. Code gender, like for most likely male or female is category, etc. So it's kind of makes sense. There are also not treated columns. We should care about here are categories in application train, blah blah blah. So you check this categorization, and of course it doesn't work well always. So since these are just data frames in this inside this EDA object, you can always modify them. You can change some categories by hand, and what is nice, you can call every data frame with using just EDA.data.some data frame, like name of this data frame, which is inherited from the file name, but also converted to a snake case. So you can call this data frame, you can change it, you can do everything you want. And after categorization is completed, you call EDA.next, and now it's in categorized state, and now it's allowed to use some nice shortcuts. For example, imagine that you have some I don't know, target variable, which is binary, or just some binary category, and you have some important numeric category and important numeric column, and you want to just compare distributions for these two groups. So you could firstly, for example, create some box plots with confidence intervals, and you can also compute some statistics. You need to remember what to import from that, etc. But what you can do with EDAwesome, one second, you can call EDA compare distributions, and you say, I want to use application trained data set. I want to use external source 3, doesn't matter what. This external source is just some numerical column, and you want to compare this numerical column by target. And here it plots EDA plots, it plots box plots with the means, as I remember. And it also compares it with a t-test. It says, so, well, p-value is less than something. I believe you can set up alpha, and you reject null hypothesis. So you can very easily do it. Also, let's say you want to check for outliers. So you can use EDAwesome QQ. Here's just, and you just want to check some distribution. So here is the graph, and this boxon plot is mostly to check some outliers. If you see some points, it's not nice. And QQ plot just to check general distribution. And what else? Again, EDA plot for it's not from EDAwesome. So basically, you just have such shortcuts which you can check, and you have you kind of have this structure of the notebook by default. So when you use EDAwesome, your EDA becomes a bit more awesome. So let me
sharing again disappeared.
That's because it kind of ended.
Okay, maybe you still can share something. Just
yes, I want to share just EDAwesome page. So for now, it's not so huge. Here's just a very quick introduction. I also tried to use poetry. I'm not sure that it's a good idea, because in data science, all the people use Conda, but I don't like it. And I like poetry, so we use poetry to manage dependencies, but it doesn't matter really. But you can also use it. It's nice, just random point. So here I see EDAwesome. We have. Let's open the docs, by the way. So as I mentioned, we have some. We already have kind of structured collection of tools, which is pdapply, pdhelp, just some other functions which work with data frames, but cannot be just applied to the data frames. Some other functions. SNS help charts, string help string functions, etc. Scikit-learn help. I'm not sure that these names are very good. We're probably going to change it a lot. This SNS help is just a set of tools to evaluate your models. As I remember, there was something like if you have regression, there was something like graph predicted versus true, and also some for classification, as I remember, some matrices like this true positive, false positive, but in beautiful way with SNS plot. So that's it. And we have some future plans. I'm not sure that I've included this into, yes, I've included this into presentation, so I will demonstrate it again. Firstly, I guess it makes sense to create not only one sec, I will share not only clean method which stupidly drops, but also something like impute in a meaningful way, like some kind of default way to impute the values. Also, it would be nice to create lazy SQL functionality. Like when you work with huge databases, it probably makes sense not to load it into pandas, but just to load when you need it and load with some limits. By the way, there is also limit a parameter, like when you just want to, I don't know, as a beginning, check only part of the data, you can set up load limit, and it will cut off all the data frames by this limit, using this limit. Also, since this library is very high level, it probably makes sense to even create some GUI. My ideas are Jupyter widgets, which I'm not familiar with, but as I understand, it's not so difficult to create Jupyter widgets, like something where you just push the buttons next step, and you, I don't know, do something, and you can mix it with the code or something like this. Also, there is still Streamlit, which I also like. Probably it's also an option. Also, as you remember, I mentioned some boxes, like we need some standardized boxes where the users can place their custom functions. So I believe we will just create such functionality. Then when you create EDA object, it automatically creates the models that are standard, or for example, you can kind of register some function with some decorators, because the decorators are nice. You can register some function as loading function, and it will just load it. And it will, in this case, it will just create such model, and so it probably write it or into this module, or you can write it by hands. I think it's a better solution. So something like this. It kind of, when you start your EDA, it creates just some structure. Probably it makes sense also to include directories like models if you wanted, some other things, because sometimes you kind of combine exploratory data analysis with some simple models, and you also need this module. So we need some boxes, like obvious boxes, which are similar to all the users. And the boxes are especially useful for data loading, because I believe that we already implemented some common things, but I believe that every person have some domain-specific data loading, like some API which he or she uses, or something else. And it would be nice to create such box. And also, I believe that we will include some of the loaders into our loading functionality, and we will try to properly structure it somehow, something like, I don't know, so this type of data, like for working with APIs, for bioinformaticians, for something like this. And yeah, or I believe it makes sense to create such box and such module in our library. Also, I like Plotly, but Plotly visualizations are not included, because it really makes sense to include Plotly charts in such kind of library, because these graphs are very good, very nice, but sometimes not so. and usually people are just too lazy to use Plotly. So we help lazy people, so we can include it. Also, there are still some improvements related to loading. For example, as I remember, you can already read Excel files, but and everything which is which you can read with pandas.readexcel, but as I remember from my experience, when you work with Excel, readexcel often doesn't work properly, and you need OpenPyXL, and probably we could also include it into this library so that loading Excel always works good. Also, we already have some simple detection of auto index. Like sometimes you get this I mean, extra row, which you need to drop with something like untitled blah, 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 or some index, which you don't need. So yeah, it is detected automatically already, but still there are some concerns, and sometimes it creates some not wanted columns and rows. So basically, there are many directions which we can improve. One thing I'm really excited about is to like develop a bit feature engineering. Actually, we already have some libraries to automate feature engineering, like a lot of good tools. So it's probably not so needed, but one idea is to use these hyping natural language processing models like GPT to analyze column names. It's actually what I've already done once, and it's probably nice to even create, I don't know, simple separate project. So, for example, you have a lot of columns, and you think, okay, I will automatically create some polynomial features. There are good tools, several tools for it. But I also want to create ratio features, like something divided by something. And you usually cannot easily automate it. And you need to check that there are no infinities, etc., etc. So what we can do, we can ask some language model to generate some reasonable ratios. Like, I don't know, if you have a number of people in family, and if you have income family, it makes sense to divide income by number of people, something like this. And I believe language models can solve this problem. So it would be probably not useful, but at least fun. Yeah, and what I also wanted to add about future plans. In announcement, there was a bonus about scikit-learn, and it was actually also about future plans, because just in this December of 2029, as I remember, or 21, I'm sorry, they introduced their output formats of the transformers, so that you can don't drop the column names. And I really liked it, because I usually like impute something with scikit-learn classes for it, but after that I do some feature engineering. But I really don't like when I need to restore these column names by hands, and it's not always easy. You need some crazy solutions. I don't like it. And you can just set this output, set it even for custom transformers, which are included in some imputation pipeline. And I guess it would be nice to include it into this library so that you can automatically clean or you can automatically impute. Check it out, this new scikit-learn version. It's very nice. I really liked this syntactic sugar. And let's discuss something about like this library, like what we can include also, or how can we improve it. Maybe you want to contribute. You are all very welcome to contribute, especially at this part, which is about set of tools. We cannot create it without community. And I think we can probably already can switch on the mics.
Okay, thank you very much for the talk. So colleagues, please ask questions or comments, suggestions, whatever. Timofei, you can, I think, still share something on GitHub page or something.
One sec, I will open it.
Hi. Can I ask a question?
Okay.
Yeah, sure.
Thanks for the presentation. And I have a question. What about, or have you seen some the idea of using Dask, for example, not just pandas?
Sorry, probably some troubles with the internet. As I understood, you suggested to use some library instead of pandas, like pores.
Dask. Dask.
Dask. Yeah, I know about Dask. Yes, it's actually probably an option. I don't want to use it by default, for sure. But yeah, it's probably a good idea. Like use PySpark. You can also say something like use Dask. But I'm not sure that it's good when you have different types of data frames. It's actually the problem, because when you implement these helper functions, you need to make sure that they work for all the types of the data frames. It was actually the problem for PySpark, because PySpark pandas data frames are pandas data frames, but not always. So it was quite a trick to write all these tools so that they work both for pandas and for PySpark. And if we include Dask, we also need to make sure that it also works for Dask. So it's kind of not so easy, because it's nice when you have these high-level functions, some kind of common API which don't rely on the format of the data frames. But it's possible. But I'm not sure that it's really needed, because you already have PySpark to work with large data frames. But yeah.
Yes. Okay. That would be another question I wanted to ask about large data frames which do not fit into RAM. How do we handle it?
We handle it with PySpark. So it basically creates something similar to swap to your RAM, and basically uses just disk space. It's very slow, but it's sometimes useful. So it's just PySpark.
And one more question about loading data. do the framework expects some data structure on the disk, or it's just a plain structure with simple CSV files?
As I remember, there are some partitions. I don't know how it's managed. I'm not sure that I'm sure that it's not just CSV files for sure. Just kind of, I don't know, internal database, but I'm not sure how PySpark works inside.
Oh. I mean, how do we load data? Our data sets must be CSV files or something else. There must be directories.
Oh, yes, okay, it's a good question because I didn't mention it explicitly. So how it works? You just include some sources, and firstly it downloads something, it unzip it into your data directory, and then yes, it just looks for all the tsv and csv files, and it's actually also I think to improve that sometimes you have some files which are actually like CSV or TSV, but have other formats. So you can say something like load such files with this separator and such files with this separator, something like this, and also load these files. But for now, it just loads all the CSV and TSV files in the data directory.
What about Parquet files? Are they supported?
Not yet. So basically, this is why we need this loading toolbox. And when I don't know, when I mentioned this other table files, for example, I don't know, you have something like VCF in bioinformatics, and it's actually also a table, but it has another extension. But you still want to load it as a CSV file. But yeah, there are many things which we can also include. Also, as I remember, Excel files are loaded, but I'm not sure about that. I need to check.
As far as I remember, Excel files are loaded by some extensions to pandas.
Yes, it's Red Excel. But I'm not sure. Do we like check for Excel files in the data directory and do we load it? I believe no, but it's very easy to add. Yes.
And one more point I wanted to mention about Jupyter widgets.
Okay,
and,
I'm not really familiar with Jupyter widgets. I just know that they exist.
Yes, okay. Someday I have to work with this, and that seemed very useful for me in terms of viewing pictures. So if the data set have some pictures, we can use Jupyter widgets to create some image browser in the notebook.
It's interesting.
And it's very useful when you don't have your data set on your local computer. You just have it on some remote server, and you need to see some pictures and browse them.
Okay, yeah, it's interesting.
that would be a nice feature.
Oh,
Thanks.
I encourage you to do is to create initial, to create a pull request, or create just a pull request, and we'll see. We'll try to introduce some kind of workflow of quality control to make sure that these functions are properly written, and then we include them into the library, and in such way grow this collection. So
okay,
yeah,
okay.
good.
When I have enough time.
So yeah, it's so,
Thanks. It's a great idea to automate data analysis, initial data analysis for such data sets.
so probably like common use case is probably Kaggle competitions. When you already have this shortcut, just include this Kaggle dataset, and you just check all the data sets. You explore the data very quickly, and it can be helpful.
Please, could you comment one more, please? I've looked through the EDAwesome library, and but I have not found any notebooks, IPython notebooks with examples. Is there?
Yes, if you check the README, there is, you can control example, and here it's real world examples.
Dump please in the chat.
Sure.
Are there many examples, sir?
Actually, I wanted to create some kind of quick start a notebook and just place it here, where you, without so many data sets as in the example I've shared, because like this notebook is not actually clean and beautiful, like it's not perfect. So yes, I wanted to create some quick start.ipynb just to check it with I don't know, just several data frames, and
okay, yes, okay, thank you. Yes, I know 1, 2, 3, 4, 5 IPython notebooks. Yes, 6. No, 5. Yes, 5. Okay, thank you.
it's oh, I'm sorry, it's not the best link, but you need 1 second. What I've shared. Yes, it's one. Yes, it's some IPython notebook. Yeah. I'm not sure that in the other notebooks this this EDAwesome is used only in EDA IPynb. But I think if I won't be too lazy, I will create this quick start, because this is not really like the best example, because it's too huge, and we need something more concise.
Okay, thank you.
So please, any other questions, comments, suggestions? Okay, so if no, then thank you very much for the talk, and we wish you develop your library, improve it.
And by the way, start it, please.
Okay, so colleagues who have a GitHub account, please make a star for Timofei's library.
Yes. I don't know why I need stars, but yes, I need.
Okay, it's yeah, not bad to have. Okay, so thank you very much again, and colleagues. Okay, good evening to everybody. So,
Good evening.